Hello everyone, we are here to present our final year BTech project called Bodhini, made under the guidance of Dr. Yogesh Mari with the grace of our HOD Dr. Rachna Sabde and our campus director Dr. R.D. Kharadkar sir. I am Padmaj Nikam and my fellow projectee is Sarthak Zada, and this is Bodhini.
Hello guys, I'm Sarthak Zada, and we are looking at the code base overview in which we have a manifest index, we have a Bodhini front end, and we have our Bodhini backend, which all are gated separately. In our Bodhini front end, we have a source code, and it is all containerized through a Docker file. Similarly, for Bodhini backend, it has its separate source code, and it is all separately containerized by the help of using Dockerfile. In our manifest index, we have our infra and k8s file required for our Kubernetes, in which we have Bodhini front end. Below that, we have two file structures, which is base and overlays. In our base file structure, we have service.yaml, customization.yaml, and deployment.yamls. Similar goes for overlays, and overlays has its separate feature branches and staging branches. So now we are looking at the deployment strategy that we use for Bodhini. So whenever a feature branch or code is modified, a container is built by using Docker. It is pushed to the GitHub repository. After that, we have something called as Argo CD, which looks and fetches the code through the GitHub repository and then applies it to the production and main branch. Then this is a branching strategy in which the bottom part of the table is automated. There is a feature branch, there is a development branch, there is a main branch, and there is a release branch. And through this process, the code flows to the main cluster, from development cluster to the main cluster.
Now we'll be doing a code review. Now, if you can see, we have around 5 different services which are deployed in order to run this particular project. Number 1 is our authentication service. Number 2 is our tenant service, which takes care of the users and the user management. Number 3 is the portal, which is the front end. Number 4 is the notification. And number 5 is the build pack Python, which is the backend service. Now all of them, the infrastructure code is stored in infra file over here. The models code is stored in the build pack Python service, and here is the models code. The model, that is the customer churn prediction model, is a simple logistic regression model which takes in account the CSV that we provides it, do churn prediction onto it, and serves us with an output CSV, which then is tallied by our portal, that is the front end. The backend route which generates the output CSV serves it through the front end through this particular route, that is the customer churn output screen. Now our front end is a React based front end, and herein we have established communication between all the microservices using our Kafka topics. Now this is all about the code review that we have with us. Our project is Bodhini, your pocket data analyst. Now you might say the name Bodhini sounds very unique. Why the name Bodhini? There's a backstory to it. My mother is a textile retail business owner, and two of the problems that occur very often in our business is, number 1, that customers oftentimes switch from doing business with us to doing business with our competitors. We lose customers at the same pace that we gain customers. And number 2 is that a lot of our money gets stuck with dead stocks which goes unsold for months and months and months altogether. And these are the two problems which number 1 takes a hit on the business revenue, number 2 takes a hit on our on the business growth. So in order to acquire reacquire and sustain relations with customers, And in order to efficiently invest our money, our capital into our products, I came up with Bodhini. Now Bodhini has two different models into it. Number one is a customer churn prediction model, and number two is an inventory optimization model, both of which are deployed on a machine learning plane which can house n number of models. Now as you can see, the front end is built using React. uh, we have used React components to create this robust front end, which helps us generate visualizations, which helps us generate uh, great animation and everything. Number two, the backend is built using Python Flask. Now, Python Flask is a very good option when we are dealing with number one, that is models which are deployed within the backend, and number two, with good API responses which are required when you are running compute intensive agentic AI modules. So for both the things, we went with Python Flask. Now this is a 3 repository structure. There are 3 different repositories. Both the front end and the back end repository sits within an index repository which houses the infrastructure code required by the back end and the front end. All 3 repositories, that is the backend, the front end and the index repository, are gitted separately, which helps us in versioning them and do timely releases of those 3 repositories. Now the infra is deployed on Google Cloud right now. We are utilizing Google's Kubernetes engine in order to run our services. So everything aside, let us dive deeper into the functioning of the project. This is the welcome page. This is what you will be greeted after you have logged in to Bodhini. You will be able to see 2 different models over here. Number one is a customer churn prediction model, and number two is the inventory optimization model. When you click into customer churn prediction model, it will ask you in the form of a form. It will ask you 3 different things from you. Number one is an experiment name. Every run is an experiment. That's why it's given an experiment name. Let us say demo 1 is my experiment name. Then the type of business that we have. Let us select retail over here. After that, while uploading our raw customer data, please do visit the I button, which will give us an updated data format that is required for the model to function over. Now this is the format that every business owner for sure has regarding his or her customer, which is the customer ID, the name of the customer, the age of the customer, the subscription type, usage and churn, based upon the various different churn periods or churn rates that every business has. Now let us upload our test dummy input data into it and run the analysis. Now once the analysis is run, we are provided with 2 different things from the backend model. Number one is a visualization. The visualization helps the business owner take cognitive decisions regarding the health of the business and how to get the customers back. And how to get the customers back? Yes, we also do provide an output CSV, and this output CSV contains the contact information of each and every customer which is about to get churned and is already churned, helping the business owner do targeted marketing. Now once you download the CSV, you can do your targeted marketing as per your convenience. Let us move to our second model, that is the inventory optimization model. Now the inventory optimization model is a clustering algorithm which clusters various different products based upon their category, based upon their functioning, based upon their type, based upon the product ID. This clustering helps us get a number of which is the most popular, which is the most favorable product among our customers, helping us optimize our inventory, getting that particular category, type or kind of product into our inventory. It has a similar form interface. We will be again filling in the details over here. The store type is a unique addition. The reason being that inventories are with stores only. Majorly businesses which are retail based have inventories. Again, visit the I button to know the inventory input data format. This is a basic inventory input data format which every business owner has. I need your product ID, the product name, the category of the product, the brand of the product, the sales that the product has enjoyed, the current stock of the product, the price of the product, and when was the product last restocked. Once you upload the CSV and run the optimization, the clustering algorithm will give you the distribution based upon the popularity of the product. Now this popularity will help you determine which product you need to keep more in your inventory in order to boost your revenue. We also do provide you an output CSV. Now here in the output CSV will not only give you the product which is your hero, but also the brand which is the most selling, in order to help you make more informed decisions. Now this is the functioning of Bodhini. We have two different agentic AI models onto one machine learning plane. Both the models on this machine learning plane function independently, communicating with each other using Confluent Kafka. We have Kafka topics defined for both of them. We have listeners for both of them. Both of them have separate Mongo database collection, and all the data is stored in object format in our Mongo collection. The reason being that processing it is much faster. And now this is Bodhini at your disposal. Any business owner who is not a technocrat can utilize this particular product on their system, which is a laptop or a PC based system, or even a mobile system like your smartphone. And it is very lightweight. Right now everything is on cloud, and cloud resources are utilized in order to process the data. So thank you so much. This is Bodhini for everyone. I am Padmaj Nikam, my teammate Sarthak Jadhav. We are team CA1 from GH Raisoni College of Engineering and Management, and this is our final year project.